Today we're going to talk about Lesson 1-4, Graphs of Functions. Because a real function is a set of ordered pairs of real numbers, we can graph that on a coordinate plane. A real function is a function whose independent and dependent variables stand only for real numbers. Remember, our independent variables are our x values, our dependent variables are our y values. That's important that you remember that. We're going to be dealing with that all the time. You can graph a real function on a rectangular coordinate graph if y equals f of x. Then the coordinates of the points on the graph have the form x comma y, or what they call x comma f of x. This is function notation. Okay, this is the standard way of writing it as equations. An example from driver's education. When a driver attempts to stop a car, the distance d the vehicle travels before stopping is a function of the car's speed x and can be modeled by the equation d equals x plus x squared divided by 20. If we give the name c to the function, giving the stopping distance, then c of x is equal to x plus x squared divided by 20. Several ordered pairs of this function c are shown below. Okay, so if you look at this, if your car's speed is 0, obviously it's already stopped. 10 miles per hour your car is going, it takes 15 feet to stop. 20 miles per hour, 40 feet to stop. And all the way up here, 70 miles per hour, it's going to take 315 feet to stop. Okay, so just a little bit over the length of a football field. On the following page are two graphs relating the data above. The graph at the left is a graph of the function c for values of x from 0 to 70. All the points on it are of the form x comma c of x. To find the value of c of 60 from the graph, start at 60 on the x-axis, read up to the curve, and then across to find the value on the y-axis. So, c of 60 is going to equal 240. Notice that this agrees with the value in the table above. We're going to look at the table in just a little bit. The graph at the right includes the graph of a second function s. S maps the speed x of an SUV, sport utility vehicle, onto its stopping distance. Let's take a look at these two. Okay, so here is your car stopping distance equation. Okay, notice its shape. Kind of like a parabola or half of a parabola. Okay? And here is an SUV's stopping distance compared to the car's stopping distance. Now, why do you think an SUV takes longer to stop? As many as you should say is the fact that an SUV weighs more, therefore its stopping distance is going to take a little bit longer than what a car is. Now, when we're not going as fast, it doesn't take that long for that SUV to stop. But as we start getting up to 30, 40, 50, 60, it does take an extreme amount of time for it to stop. That's why you need to give leeway when you're driving a bigger vehicle. Domain and range. For the function c and s on the previous page, the situation and table determine what values of the independent and dependent variables to include in the graph. The set of allowable values, this is what you need to know. The set of allowable values for the independent variable is called the domain. So it's what values you can put into x. Okay? It's what values you can put into x. Now, in this case, the allowable speeds for both c and s are from 0 to 70. So the domain from each is x such that 0 is less than or equal to x is less than or equal to 70. This is called set builder notation. You need to get familiar with it. You're going to use this a lot. X such that 0 is less than or equal to x is less than or equal to 70. It's very easy. What are you talking about? You're talking about the domain. So you use x such that here's the lowest in the range, here's the highest in the range. Okay? The range of a function is the set of values for the dependent variable that can result from all possible substitutions for the independent variable. So it's what you can get out, okay? You put numbers in from 0 to 70, you get numbers out, okay? So according to the table, when x has values from 0 to 70, the range is actually from 0 to 315 because it takes 315 feet for that car to stop. So the range for C is y such that 0 is less than or equal to y is less than or equal to 315. Ranges are y values, so that's why you say y first. Y such that 0 is less than or equal to y is less than or equal to 15. This is the lowest part of the range. This is the highest part of the range. For our SUVs range, it goes from 0 to 480. So we have to doctor this up and change it from 315 to 480. When graphing a function on a graphing utility, you need to consider its domain and range in order to get an appropriate picture. We dealt a lot with this in Algebra 1. The bigger you make your window, or the more understanding your window is to you, the more of the graph you're going to be able to see. Okay? If you don't know how to do that, please come talk to me, and we'll fix that. So, let's look at this picture. We want to determine the domain and range of these two functions. Now, we just kind of talked about it, but let's actually go through it. Okay? Our domain is the set builder notation x such that, because domain are our x values. Where are x values located? They're located right across here. Our x values go from 0 all the way to 70 on this. So it's 0 is less than or equal to x because it can equal 0. And is less than or equal to 70 because it can't go anywhere above 70. So that is my domain. It's the values that my x values can be. My range is y values, such that my y values go from 0 all the way up to right here, 315. So 0 is less than or equal to y is less than or equal to 315. Over here on the SUV, that's the one in the red. My domain goes from 0 all the way over to 70. And my y's go from 0 all the way up to 480. Okay? Simple enough. X is left to right, domain left to right, ranges up and down. Some sets of numbers that you are probably familiar with are frequently used as domains and often appear as ranges. These sets of numbers you need to know. Make sure you write these down. The set of natural numbers or counting numbers. Natural numbers are 1, 2, 3, 4, 5, 6, etc., etc. They are the numbers that you count with. The set of whole numbers. Whole numbers are your counting numbers and 0. So 0, 1, 2, 3, 4, 5, 6, etc., etc. The set of integers. Integers are your negative and positive whole numbers. Okay? Negative and positive whole numbers. So we're still dealing with whole numbers, but we also have their negative ones as well. The set of real numbers is any number that can be represented by decimals. Okay? That also includes integers. Real numbers are everything. Okay? Rational numbers, what a lot of people get mistaken about. Rational numbers are numbers that you can write in the form a divided by b. You can write it as a fraction. Okay? This also includes terminating decimals and repeating decimals. terminating decimals and repeating decimals. Here's a terminating decimal. Here's a repeating decimal. Okay? You can write those as a fraction. Now, someone might be saying square root of 16. Well, what's square root of 16? It's 4. How is that written as a fraction? Well, 4 over 1. Okay? The set of irrational numbers are real numbers that are not rational. So anything that's not rational is irrational. Examples of this are pi, because it goes on forever, square root of 5, square root of 10, and e are numbers that go on forever, they don't terminate, and they do not repeat. That's all I have for you today. Best of luck. We'll see you tomorrow.